Okay. Yes. This is let's see, example. CPS word. We're going to talk about join points here. Case of case. Okay, case of case. That's a good place to start. Okay. Right. Okay. So we often want to move things inside the case statement, right? This. It's not intended to be a lightning talk, so okay. Let me see. Okay. Context domain. Okay. So, okay, let's put. Right.
I can give the talk while you do the slide.
No, not as good on my feet there. Okay. Right. Okay, so what's going on with this code here? It's the inner loop there is either going to return just or nothing, and whichever one it returns, you know which branch of the outer that it's going to go to, right? It's going to produce, it's going to heap allocate a just in that case, or it's going to return a nothing, and it's just going to be eaten up immediately. That's our problem here. There are loops in nofib there are programs in nofib that where this is the only kind of allocation that happens. Even. So if we can get rid of this, we can get rid of all the allocations and a few of those things. So what we'd like to do, kind of, is take that case, that context there, and saying, okay, maybe we can make a special version of the function. Where we kind of build that in, that we know that's the context in which it's being called. And then the case of case transform happens as it normally does, which, well, okay, helps at first, but now we haven't actually made any traction because we're still right back here. So yeah, okay, then CPS has a way of helping out. Okay, yes. Right, okay, so in CPS, we see that this is the version of CPS. There's nothing immediately magical happens, but you can see that this continuation argument is always known at compile time. And so we can kind of move things around a bit and end up inlining things in there, and it actually goes away. The just and nothing goes away, which is kind of slick. But there's no obvious way to make that happen for us. We'd like to. The idea of ANF is you can do CPS things without actually having it, in CPS. You can do the same sort of transforms. So there's a special thing about find. It's tail recursive, which is why we can do the static argument transformation on the CPS. Tail recursion is something we can quite perfectly well see. And okay, so we have to do a little funny thing here where we move the let inside the case. But once we do this, everything's a tail call, which is great. Because now we can make it a join point. So join points already kind of exist as a way of sharing code. We're sort of now making it an official thing in the syntax. So it's just a function that can only tail call. You're not only allowed to tail call it at all. And the important thing is because it's always tail called, we always know what its context is. It's always sort of the thing surrounding. So there's the special syntax label and jump, which is just to differentiate it. Because now I just have to keep track of that one little bit of information. But now we can move the case inside the join point body, and everything cancels out as it would like. So before there hasn't really been much we could do to get context inside a recursive function. Right? So things like fusion would often get stuck that way. Right, and here's the rules for how that works. Just the context of the join just gets stuck there, and they have to throw it away at the. I think there's something else about how fusion works, but you can guess how fusion works with fusion. Just the same thing happens. When you have for your filter or whatever. Yeah.
Time for one quick question. All right, let's thank the speaker.